Today we are going to have a look at sound and syncs. This is a video that I have wanted to make long before I even launched this channel, but there has been a slight problem, and that is that today most of the equipment sadly has been scrapped. I have spent the past 3 years constantly on the hunt for enough of this to make a video about and save it before it is all lost forever. And in recent months I had a couple of big wins and finally have enough to actually put together my first video about. Now there is going to be quite a bit to get through in today's video, so I have enabled the chapters feature. Feel free to skip to any section that you find particularly interesting. Now first of all, we're just going to have a quick introduction on the actual technology itself. So what is sound and syncs, or SiS? Well, let's say we want to carry an analog video and audio signal across a city or a country within a broadcaster network. To do so, we would need two separate links. One high bandwidth link for the video and another lower bandwidth link for the audio, which is typically provisioned and billed separately. However it is done in practice, it's all pretty expensive. A rather long time ago, in the 1940s I believe, the RCA company had the idea of trying to squeeze both signals into one link, specifically to use the synchronization periods of the video signal to carry the audio. And this makes a lot of sense because while vital to televisions, in distribution and transmission, sync periods are wasted bandwidth. Though the concept came from the NTSC world, today we are talking about how it was utilized in the United Kingdom, one of the largest PAL regions. Two generations of the technology existed. The first was developed in the 1960s and digitized the audio as mono PCM. The second was based on NICAM 728, which was widely used for television audio throughout the PAL world. We're going to start off with a quick introduction to the equipment that we have for today's video. Now, as the thumbnail suggests, we have two different systems here. We have the BBC's system and we have the IBA's system. That's Channel 4 and ITV. We'll start off with this one. There's actually quite a bit of information about the mono predecessor of this system out there already, but for this stereo successor is unusually mysterious for the normally open BBC. I've only been able to find maybe 3 or so paragraphs of text which actually talk about it, and they don't really say very much. And this has fostered a good bit of speculation about how exactly this system is built and how it works. Well, fortunately we have a full working setup here and we're going to be doing quite a few demonstrations and experiments with it, so we'll get to know it pretty well by the end of this video. Now unfortunately we don't have any documentation for this system, and I did reach out to a number of contacts and that didn't turn up anything at the present time. If anybody does have any leads that I could possibly pursue to find the documentation for the system, please get in touch. Now for the IBA equipment, unfortunately we don't have a full working setup here, we just have this coder. And I have tried to find the decoder for this, but everybody that I've asked has told me the same thing, which is that all the equipment has been scrapped. I'm hoping that there might be a few pieces out there somewhere that we can get on the bench and have a look at one day, but today this is all that we have to look at. And we are going to try to do our best to look at this system with only one half of it. Unfortunately, we have something else. We have the full awesome documentation for this system. We're talking sort of 500 or so pages of manual here. And have I scanned this? You bet I have. The link is in the description. If you have a chance, take a look at it, because I can assure you, you have never seen a manual like this before. And having the full manual has allowed us to learn exactly what sort of company and equipment we're actually dealing with here, because up until this point, it has been pretty mysterious. I shared this around with a few friends just to help me digest it all, and what we found is that this is a thoroughly engineered solution, and this is coming from a people with particular attention to detail. Anyway, that's the quick intro for the equipment, so what we're going to do now is roll an introduction to the companies behind this, because this one in particular is quite obscure. Just about everybody watching this will have heard of PYE, but you might not be so familiar with PYE TVT. This was a division of PYE which designed and manufactured equipment for the television broadcasting industry. Long story short, TVT made a ton of stuff and they sold it to every corner of the globe. There is no questioning its significance in the history of television engineering, but in hindsight, the monochrome era unfortunately was the heyday of the company. A series of management blunders left the PYE company's finances in poor shape by the mid-1960s. Sniffing an opportunity, the Philips company immediately put in an offer for the ailing British giant. The government didn't initially allow them to buy it outright, but eventually they gained full ownership. Life for TVT within Philips was a mixed blessing. On the upside, they now had access to the massive resources of the Philips company, And being a solutions provider, TVT was able to plug gaps in its own portfolio with products from other divisions of Philips. But on the downside, being a former competitor, TVT was duplicating some of the efforts of other established Philips businesses, leading to inevitable internal struggles. We are skipping over a whole lot of history here, but in 1986, Philips decided to throw in the towel and sell off the entire PYE company. The fate of the other parts of PYE are not really something for this channel to dwell upon, but in 1987, TVT would find itself in the hands of the US domicile company Varian Associates, which is why its name appears on the front panel, and only just. Having only owned it for a few short years, Varian then sold it on to Harris, who subsequently closed it down. Though I haven't seen it with my own eyes, I have heard reports of this equipment in Harris branding. I don't really think either company is of any significance in the history of this equipment, which is why their logos don't appear in the video thumbnail. While all of this was happening, the Philips company was busy making massive blunders of its own, such as Video 2000 and CDI, which would send the Dutch giant into a downward spiral from which it has never escaped. I guess nothing is forever. Next up, it's time to talk about an even more obscure company. But first, why we're even talking about it at all. At the time, the BBC's main competitor was the IBA, an engineering and regulatory entity shared by private broadcasters Channel 4 and ITV. Like many others at the time, they were looking to roll out NICAM stereo. Being UK-based, why not just buy the kit from TVT, right? Well, this has to do with the shape of stereo sound engineering in the mid-1980s. Precise details of what the BBC and TVT were up to at that time remain elusive. However, it is thought they were attempting to cobble together a deployment based on two incompatible types of NICAM, 676 for distribution and 728 for transmission. Recollections of discussions between the IBA and TVT confer with this. Engineers at the IBA were skeptical. Suspecting the BBC's stereo efforts were headed for the buffers, instead the IBA headed to Denmark. The company in question is RE Technology. Its exact origin is unclear. Some say it is a spin-off of the Danish medical company Radiometer. Others say that it was a startup founded by former employees. Whatever it is, it definitely has something to do with it, because according to folklore, RE stands for Radiometer Electronics, but I have to stress, I have not yet seen that written in any materials from the company. RE was sold to Barco in 1997, making it rather difficult to research. The company was primarily focused on products for audio and video digitization and distribution over telco networks, but also built various other super niche items such as FM radio test equipment. I wasn't able to find any headcount or turnover figures, but from studying its product portfolio, I reckon it employed 200 to 300 people. Handing the contract to RE Technology was a gamble for the IBA, because this is a company with precisely zero experience in either SIS or NICAM, but in just a few short years they pulled it out of the hat and delivered a beautifully engineered solution, beating the BBC to it. And to be fair to TVT, after a much needed rethink at the BBC, they also came up with a decent solution. Ironically, one rather similar to what had just been built in Denmark. And just a small correction to the slide from video number 2, which was about NICAM. The first known NICAM stereo public launch is now 1988 in Denmark. Of course it was. And on that topic, why did it take another 3 years in the UK, the very birthplace of the technology? Well, that's what today's video is going to be about. Before we get into the sound and syncs equipment, I thought it would be fun to put together an experiment to see whether or not we can recreate one of the big issues that held up the deployment of stereo sound in the United Kingdom. Now, this is not SIS equipment, and this is precisely the point. The equipment here, for those who are new to the channel, this is all coming from PTV. This was a division of the Danish Philips organization, and like TVT, these guys were also eventually sold off. Pro Television is a name they use under a brief period of private equity ownership, and it doesn't sound like that ended very well. Anyway, the setup here is that we've got two pretend studios, and I've just labeled them Alpha and Beta, just the bare minimum equipment, and we have a source of NICAM at each, and we also have a source of a video test signal. This one here is acting as a master SPG, this is a slave. And this is one of the things that was quite special about NICAM stereo in the UK, in that the coders lived at the source of the audio, whereas in most other countries it would have lived at the transmitter. I'm not going to say that was the case absolutely everywhere, but I think for the most part we'll find that's how it works. So what we're going to be doing is basically switching the outputs of these two through this matrix switcher here. Let's just quickly go around the back and have a look at how it's all hooked up. So we'll start off on the video side of things. Now, as I said, we have two sync generators here. This one is the master and this is a slave. These also have test pattern generators built in, and they're generating the Phillips pattern at the moment. The master sync generator has two black and burst outputs. One of them is going down to the slave down there. So this one is gen locked to this unit. The second one is going up to the matrix switcher, and because this is a synchronized switch, and we ideally do want to be switching in the blanking periods if we can. Additionally, we have our two NICAM coders here, and these units actually do have RF modulators built in of differing standards, but we're not actually using that functionality at all today. What we're doing is taking the baseband digital outputs and we're feeding these straight into the video matrix switch. Now, you might be thinking, what the heck? Well, this interface here happens to be electrically compatible with composite video, and we can actually quite easily switch it inside a matrix switcher like this one. And coming out of the matrix switch, we've got two connections where we've got our video outputs and our NICAM audio outputs. And these two connections are headed off to our pretend transmitter, which we will have a look at in a minute. Now, there is a kind of interesting question about how, in the real world, how does this NICAM digital connection actually make it to the transmitter in this type of scenario? Well, previously we looked at that RE technology video coder. These things were actually able to be ordered with an option where the built-in analog stereo interface could be swapped out and replaced with a NICAM pass-through. And the NICAM pass-through has this this 75 ohm BNC type connection on it. So that is one way that can be done. I doubt that was done very much in the real world, but definitely was something that they had available. So anyway, let's head over to our transmitter and have a look at it. So this is our pretend transmitter and receiver, and certainly this equipment here, we've seen this a good few times before. I'm not going to turn it around because this whole setup weighs about 30 kilograms or potentially even more. It's a lot of work to lift this up and turn it around. I think we already looked at the back of it in video number 6. The output of the switch that we looked at earlier is coming into these two units. So the vision signal is going into this vision modulator, and the NICAM digital audio signal goes into this NICAM modulator. This is a pretty dumb item, so digital in and digital QPSK carrier coming out, really not much going on in there at all. The outputs of these two are combined into this up converter unit, and from there it heads on to the receiver. I also have this monitor, and that's connected to the modulator. This is just here for demonstration purposes. We'll talk a bit about what that's going to be demonstrating when we switch all of this on. At the receiver, I'm using this NICAM capable VCR because my TV doesn't support NICAM, and the audio from that of course will be going into the TV via SCART. So anyway, that is the setup. Let's go and switch it on. Okay, so we've got our pretend studios all powered up here, and before we get started there's a couple of things we just need to quickly do. First of all, the slave sync generator, we just have to put that into gen lock with the master. In reality, there's a bit more to it than this, but we'll perhaps have a look at that another time. The other thing that we have to do is set the NICAM modulators to internal audio. So this basically means they will generate a 1 kHz tone, and I believe that tone is digitally generated. Certainly that's all we need for this demonstration. So the only other thing to do is the actual switching. So we're using this switch box here, and it actually does have the ability to switch two outputs simultaneously, but it's a bit of a hassle to do it from the front panel. So I whipped up a little piece of software so I can just do it with a button press on my PC. So just clicking the button now, you can see that there's only two outputs changing. So the video output goes between ports 1 and 2, and the NICAM audio output goes between ports 3 and 4, just like that. So now that we've got all this set up, let's fire up the transmitter and receiver and see what we get. Okay, so we are up and running and presently just running off the FM mono audio. Let's try some switching and see what happens. So as you can see, that switching was really clean, and we'll just do a few more switches now. all you can see is the station ID text changing and the clock appearing and disappearing, and that's because I don't have the clock option in this Alpha SPG. So what we're going to do now is switch on the NICAM modulator and inject some NICAM into the equation and see what that sounds like. Okay, so our NICAM is switched on, and at the moment it sounds exactly the same as it did before. Let's try some switching. So yeah, it sounds awful. The video is still absolutely fine, but if we look at down at the VCR, the NICAM stereo indicator on the LCD is flashing off and on. We've got this message on the screen, and also if you look at the NICAM monitor above the transmitter, the alarm LED is flashing, and this is indicating that something is wrong. Anyway, let's switch off this noise so we can talk a bit about what's going on here. So what's happening is that the NICAM decoder in the VCR is losing lock with the source and is having to resynchronize, and while it does that it drops back to the FM mono audio, which is why you hear that sort of change in the sound. Now this might seem like an awful lot of equipment and mucking around to reproduce something that seems fairly trivial, but this was a big deal for stereo sound in the UK, and it did hold things up quite a bit. The solution to the problem here is to add what's called a reframer before the NICAM modulator, and this gives the receivers the semblance of receiving from the same coder, even though in fact it is actually being switched. And such an item didn't actually exist in the late 1980s, and both the BBC and the IBA were scrambling to have them developed. I'm not actually certain whether or not Philips ever developed such an item. I've never found a full list of all the things that they made. If they did make one, it probably didn't come till a lot later on, and probably didn't sell very well. Anyway, so I think we've done a pretty good demonstration of this problem here, so it's time to put all this equipment away and get out the SiS equipment that of course we came to this video to watch. So this is our new Sound and Syncs based studio, and it is completely different to what we had before. At the top here we have our SiS coder. This here is a NICAM tester, and the reason that I've put this here is because I have seen internet forum conjecture questioning whether or not this solution is based on NICAM 676 or 728, and that's a fairly valid question to ask because of course we know there was a solution based on 676 which was abandoned. This definitely isn't it, and I really want to show that this is using 728. And down the bottom is our PM5534 test pattern generator, which we saw a couple of videos ago. I just wanted to get it out again. So what we're going to do now is turn it around and once again have a look how everything is connected. So we're going to start down the bottom at the test pattern generator. So we have two connections on here. This one's headed off to the oscilloscope, and we're using this one to trigger the oscilloscope because you can't trigger off the SiS. This one here is another video output from the test pattern generator, and it's going into the video input of the SiS coder. Notice this little blue connection here. That's a 75 ohm termination because this is a high impedance input. You can either loop this through to another piece of equipment or terminate it. If it is not looped, it must be terminated, otherwise it will not work. Down the bottom here we have the SiS output, and once again there are two of them. One is headed off to the oscilloscope so that we can look at it, and the second one is headed off to our pretend transmitter, which we will have a look at in a minute. Now there is another rather obscure connection here, and this is this auxiliary output 1. This is the TVT equivalent of the 75 ohm B and C serial output that you see on the Philips coders. It's kind of weird and proprietary on this equipment. This is an interface converter in here which is powered. We'll talk a bit more about that in a minute. And that goes into the NICAM decoder here. And like the encoders we saw earlier, this also has an RF demodulator, but we're not using that feature, we're just using the digital input at the moment. Now other connections of interest is the audio input here, and realistically these things can be used with really just three connections: the audio input, video and SiS output. Everything else is optional. So if we just unplug this one, it's actually kind of interesting. It's a 5-pin XLR, and it's actually a stereo balanced audio connection. Stereo on 5-pin XLRs is a thing, but it is my understanding that the gender is typically the opposite. So for an input it would be a socket, whereas that's actually a plug. So I had to make up these little adapters to convert between the two. Power wasn't plugged in there, and I've got an equivalent for the other end of it. There's various other connections on here, and we'll just take a minute to explain what these are. And I have to stress, as I said before, I don't have any documentation for this equipment, so this is a bit speculative. But monitoring this big DC37 connector here, I would guess this is a bunch of GPIO or TTL type interfaces connections, which probably are asserted when various things go wrong inside the unit. Auxiliary input. I think this is the equivalent of the serial NICAM input. It's probably a connector that mates with that output down there. I don't know, I haven't really looked into that very much. Remote control, this will be how the unit is configured, so there are various options, so you can set whether or not it's stereo or dual or mono. That's some of the connections I would expect to see on that interface, but I don't ultimately know what can be done with this at the present time. Control and additional data in. I think that is the same connection that we see on this Philips decoder here. So NICAM has a few spare bits where you can stuff extra data into the frames, and it works out to be a few kilobits a second of auxiliary data. And you could feed that into this connector and hypothetically receive it out of that connector if using this particular decoder. And I don't know if this is a standard pinout or if this is proprietary. We know the pinout for the Philips one because we have some documentation for the successor of this, but and we have no documentation for this at the moment, obviously. So anyway, that is our setup. So what we'll do now is turn it back around and switch it on. Okay, so we're now sort of up and running. Our SiS coder is powered on, and our NICAM tester is showing that we have NICAM 728 present, but the test pattern generator is presently switched off, so we're only half in operation at the moment. Now before we switch on the test pattern generator, let's have a look at the LEDs inside. We've got a couple of warning LEDs on here. This red one says sync fail, and this yellow one says no field syncs, and this would be indicating that we've got no video input, obviously. And this one here says standby, so the system is not really in a full operating state at the moment. So let's switch on the test pattern generator. And straight away we see the SIS data burst on the oscilloscope there, and the inputs to the SIS coder. That's the horizontal synchronization period, and that's of course it with the data burst inserted. And looking at all the LEDs, everything is switched off. We just have these 4 warnings over here saying that there's no external NICAM. Anyway, so otherwise we're basically in operation, and we can head over to the transmitter and have a look what's going on over there. For our rear view, we're going to focus our attention on the SIS decoder because of course that is the main equipment of interest here. Now this cable here is coming from our Pretend Studio, and that of course is the SIS data burst and video, and that's heading into the input here. And this is a high impedance interface once again, which has to be terminated with that 75 ohm termination. And this connection here is the video output, and this is basically the recovered video. So the SIS burst has been stripped out, and this has been returned back to a normal sync, and that heads on to the vision modulator. This here is that same connection that we saw on the coder, but labeled auxiliary outputs 2 for some reason or other, but it appears to have the exact same pinout as the one we saw on the coder. And this connector is really special for this system. This basically is what allows us to have this end-to-end digital audio, which really is quite unique to the United Kingdom, where the audio is digitized at the source, and it remains as NICAM 728 all the way through to the viewer. So this piece of equipment basically brings the audio in through this cable in digital form, then it exits here in digital without having to go back to analog, and that's just really neat. However, you'll notice that there are some analog interfaces on here. So we have an audio stereo output, which is a 5-pin XLR socket. And we also have this audio output mono, and you'll notice that's a 3-pin XLR, so that's just a standard connection there. What this is used for is the FM mono on the modulator, and this is another thing you might not know about NICAM in the United Kingdom, is that even if you didn't have a NICAM capable receiver, your audio was actually coming to you via NICAM anyway through this equipment. It's just that the NICAM was stripped off and converted into a mono audio signal at the transmitter, which is what your low-cost equipment is actually receiving. Now, for those people with a bit more money, of course, they're receiving through this here, and this one, of course, is going to our NICAM modulator, that PM5686 from the previous demo. There are some other connections on here, and these appear to be similar to the ones that we saw on the coder. I don't know what remote control would do on this unit. There must be a few things that can be configured on it. Monitoring, that's going to be a bunch of TTL alarms. And that's the opposite of that control and additional data that we saw on the coder. I have heard that this is used for like really low quality voice connections. Would be interesting to know if there's any actual confirmed sightings of that in the real world, because the bitrate of this is so low that does seem a bit unlikely to me, but I'll leave that open to comment. Now, I have heard scandalous rumours that in some locations in the UK, this magical digital connection wasn't actually used, and they actually, in the transmitters, they were connecting the analog stereo output into an off-the-shelf NICAM modulator, like that Philips modulator that we looked at earlier. And this is just ridiculous. Like, why would they do this? Well, I have a possible theory why that is, and I think it's actually right in front of us here. The serial data output on this SIS decoder is this funky proprietary interface. Now, let's suppose the year is 1995 and TVT has long since been shut down, and whatever hardware was originally attached to this is no longer available, and you want to set up a new transmitter. You have the SIS decoder, but you don't have whatever equipment plugged into this. Well, then you've got a slight problem. And this interface here is a line driver which converts TTL to this 75 ohm bipolar type interface, inverts the polarity and what have you. This took me quite a lot of time to build this, and for inside of an organisation like the BBC to engineer any custom hardware is very, very costly. Realistically, hooking an off-the-shelf modulator up to this connection here, this is the sort of thing that anybody who knows which end of the soldering iron is hot could do, and that could be done for very little money, and it's actually going to work pretty well. So that's why I think that this might have been used in some locations, as absurd as it sounds. Anyway, let's turn this back around and switch it all on and see how well it works. Okay, so our pretend transmitter is now powered on, but with the SIS decoder this time. And another piece of equipment I've added is the 5655, and I just put that there because it's nice to have something to generate a standby signal, because presently this is not actually connected to our pretend studio. So just as before, we're starting off in the disconnected state, and we can see we have a whole bunch of warning LEDs on here, these three being the most specific, and these are indicating that we have no input. So let's plug in the input from our pretend studio. So straight away we can see that the warning LEDs have all switched off, and the system good LED is now switched on. Looking at the oscilloscope, we can now see the input and the two main outputs from the SIS decoder. The yellow trace is of course the SIS input, which is a composite video signal with the data burst inserted into the horizontal sync. And the blue trace is the video output. And notice that the horizontal sync has now been returned to what was fed into the coder. And this is a key important point that I really want to get across about this system, which in the past some people have maybe not necessarily taken in, is that this signal here, this yellow signal, the viewing public never receives this. They only receive this recovered video signal. The data which is in this burst here is actually this purple trace down here. This is the NICAM serial bit stream coming out of the decoder. And in terms of what happens with this bit stream, well, there's a number of different things that can happen to it. It can go into the internal decoder, it can go into the internal monitoring decoder, and it can also, as I say, it appears on that external interface and can be fed into a NICAM modulator digitally. Anyway, that's just a quick summary of the actual signals. The next thing I want to talk about is that reframer, and we actually do have a reframer in this unit. That is, it's right there. Now, unfortunately, I'm not in a position to fully demonstrate the reframer. In order to be able to do that, I would need to get my hands on a second SiS coder, and I think that's fairly unlikely that that's going to happen. But we can partially see how it works. Now, what we're going to be doing here is paying particular attention to the NICAM monitor. Now, remember in the previous demo, when I was switching the source, this alarm LED was flashing off and on, and we could see on the display that we were losing the source. What we're going to do now is disconnect the SiS coder from the decoder here and see what happens. Now notice that that alarm LED did not flash on, and there's really no indication that anything has changed at all whatsoever on the front panel. We can hear that that 1 kHz tone is lost. And what's actually happening right now is the reframer is generating digital silence and inserting it into newly generated frames, hence the name. Anyway, I apologize I can't give you a better demo than this, but I think this gives us a pretty reasonable idea of what it can actually do. Now it's time for our first experiment, and for this I got out the PM5570, which we saw a couple of videos ago. Now this is a pretty full-on piece of equipment, which unfortunately we can't really dwell on today, but the more observant may have noticed that it already made an appearance earlier in this video. And setting up sound and syncs equipment turns out to be one of the many applications for this item. But what we're going to be doing today is causing problems with it, and I'm interested to see what sort of vulnerabilities this equipment actually has on the transmission chain. So what we're doing here is feeding the output of the coder into the 5570 and then its output into the decoder. So signal very much passing through this piece of equipment. And what we're going to be doing with it is using it to introduce a number of impediments into the signal to see what sort of vulnerabilities that it has. And we certainly do have a good few controls to play around with here. So before we get started, I'm just going to take down the front of the decoder, just so that we can see the LEDs inside it, because they're always fun to look at. Plug in our speakers, so we can hear the test tone. Now let's get testing. Now the first one I want to do is the sync. We do have the ability to stretch the sync here. And let's just drag this down and see what impact this has on it. Oh dear. Oh, that's nasty. Quite a nasty sound that made on the way here, but yeah, if I stretch the sync far enough, it dies altogether. I'm quite surprised to see that, actually. I would have thought the ADC would be AC coupled, but yeah, the DC level of the sync definitely has a considerable impact on it, so not something you want to get wrong. So we'll set that back to the correct level. Next up, we can actually muck around with the video level. That's the level of the entire signal. And I'm just going to put this straight to the variable mode. The pot in this is quite scratchy, so as I muck around with it, it's going to be pretty hideous. We're presently at the maximum output this equipment can produce. And it's still going. There is a warning light on there. What's that saying? Data amplitude too high. Yeah, well, fancy that. Right, let's turn it down and see what happens. So yeah, we're now quite a lot below the correct signal level, and it's not liking that. But if I bring it up to a more acceptable level, of course that's working. So yeah, that's another thing this equipment definitely has to have set correctly, is the amplitude of the input signal. So we'll set that back to the correct level. Next up, let's play around with the noise setting, and I'm just going to go straight to the negative 30 dB range, because the lower ranges really don't add a lot of noise. So we can see a bit of noise in the signal already, but it's still going. Let's just turn it up. Still going. Starting to break up now. So at the end of the 30 dB range, breaking up a bit. Let's crank it up to negative 20 dB. Oh dear. Well, fancy that. putting a signal into it like that wouldn't decode correctly. I can barely believe that. Alright, let's turn off the noise. The last thing we have to play with here is the hum setting. Now, hum is pretty much a nightmare for televisions because certainly if it's sufficient amplitude, it's going to upset the actual sync. Whereas for this equipment, doesn't seem to mind it. When viewed in the time domain, the input signal is like pretty much unrecognizable, but our SiS equipment just doesn't even seem to care. Oh, how could this possibly be? Well, I think it's because the frequency of our hum is well outside of the spectrum of the SiS data burst, so it's just ignoring it. But yeah, if you were putting a signal like this into a TV, that would be pretty damn nasty. Well, anyway, this is pretty cool. So, as I said, this is not a comprehensive range of different tests we can throw at it, but certainly it's something that we can do with this piece of equipment, and pretty interesting to see how it actually behaves. Well, that was a fun little experiment, and it's a real shame that we don't have the RE technology decoder here, because given that these were rival systems, it would have been pretty interesting to pitch them against each other and see which was actually more robust in practice. Now for that question on everybody's mind. Well, not really, but on the odd occasion that this technology comes up in discussion on an internet forum, pretty well every time somebody will pipe up and point out that the IBA and BBC systems were incompatible with each other. So yeah, we know this. The real question is, why are they incompatible? Because intuitively they shouldn't be. They're both coding NICAM 728, they're both inserting it into the same horizontal sync period. They both even appear to be using the same coding scheme, so what's the problem? Why are they incompatible? What better place to start than the oscilloscope? Now, presently on screen we have the output of both coders here. The yellow one is the RE Technology IBA style coder, and the blue one is the TVT BBC style coder. Now, as I said before, the two of them, while they certainly on paper do code everything the same way, as in we have this quaternary encoding into the horizontal sync period, when we actually look at them like this, yeah, they do start looking rather different. So let's walk through the things that I noticed. On the BBC style coder, there's a clear constellation here. You can see these holes in the burst where there's a clear pattern of bits being transmitted, and it seems to be a fixed number of bits per burst. Whereas for the RE Technology coder, not so much. When we look at it, it almost kind of looks like gibberish. And it isn't. Because we have the documentation for the system, we know that it actually transmits a variable number of bits. So some lines transmit more bits than others, and that's why when we look at it on an oscilloscope, that it looks quite messy. It isn't messy, it's just that we don't have any way to reliably trigger on it. Now when we come back to the BBC burst, we can see another difference here, and that's that more of the sync period is occupied with this burst, whereas RE Technology have used noticeably less of it. And this is also quite interesting. So they were quite a bit more ambitious with how they actually coded the data. They're squeezing it into a shorter space of time. And this potentially may make the system less robust. And this is why I'd really love to find a decoder for this so we can actually check whether or not that's the case. And in addition to that, because we have the documentation for the system, we know that the actual data inside of here is also likely to be vendor specific. The RE Technology coder encapsulates the NICAM into another frame structure which is proprietary, which contains other control bits, and it even has a scrambling mechanism on top of it. The odds that TVT will have done exactly the same thing are pretty much zero. So anyway, there you have it. The two systems are definitely incompatible. It's not just that nobody ever tried to plug them together. Now that all having been said, what would happen if some hapless fool plugged this coder into this decoder? Well, I think we at least have to try this. Let me just reach around the back and plug in the input. Well, something's happening. So we've got two errors here. We've got a justification fail and a recovery fail, whatever that means. Suffice to say, it isn't working. To wrap up this video, we have one last test to perform, and that is to attempt to record some SiS onto a standard consumer video cassette. Now there is a question of why on earth I am bothering to do this. Well, this is actually something that came up in the comments when I have talked about this technology in the past. And since we have set ourselves a precedent of performing daft tests with this technology, yeah, we have to try this. Now, in the context of history, this is actually kind of interesting because back in the days, VCRs like the one that I have here, sometimes people would see the hi-fi stereo and Nikon digital marked on the front, and they would think that maybe a machine like this might double as a digital audio cassette machine, but that's definitely not the case. The ability to encode NICAM is not something that you would ever find in any consumer equipment, and recording of NICAM on tape definitely wasn't something that happened. But a machine like this does have an improved stereo audio capability, but it's still very much analog. But what if we had a pair of these things? Wow, hypothetically it might be possible. And we even have a particular tailwind here. I found this VHS tape which says suitable for NICAM stereo recording, BBC even. Wow, this has to work, right? In a test like this, there are all sorts of things that could go wrong, but rather than speculate, I think we're just going to press the record button and see what happens. Now, prior to filming this, I've actually pre-recorded about 10 minutes of Phillips pattern onto the tape, and the station ID text says no SIS, and that's to indicate that we're in a section of the tape that doesn't have any SIS on it. And another interesting thing you can see straight away here is that we have this Sony grey screen of nothingness, and the reason that we're seeing this is because the SIS coder is actually connected to the input of the VCR right now, and he doesn't like that very much, so it's just showing us the grey screen. So the question is it actually even going to attempt to record it at all? Let's press the record button. And we'll just leave this running for a few minutes and come back later. Okay, so we are back again, and we're now going to attempt the playback. And the first thing that we're going to do is play the VHS directly into the television, so that you can see what that looks like. And yeah, that looks about right for a VHS. It's definitely nowhere near as nice as having it directly off the generator, but more than acceptable, I think. Now what we're going to do is disconnect the television from the VHS player and connect it directly into the SIS decoder. Okay, so we've connected the television back to the SIS decoder. Let's push play. That isn't looking good. What I think is happening here is the erratic nature of the VHS playback and tape speed or whatever is interacting with the SIS decoder in an undesirable way. So we're getting this kind of wobbly picture. Now this is not necessarily a problem in terms of the decoding, because the decoding of the SIS is done asynchronously, so maybe there's a possibility we could get the audio. Now pay particular attention to the LEDs on here, because we're not yet in the SIS part of the tape as this would indicate. And also have a look at the oscilloscope. So we're now in the SIS part of the tape. It's not looking as bad as I thought it would be. Interestingly, the sync recovery process seems to be working, but oh yeah, it's pretty nasty. And looking at the oscilloscope there, looking at that data burst, oh, ouch. Yeah, I mean, this is making our noise test look quite leisurely in comparison. Now we do actually have the audio hooked up here, but I'm not hearing any sound coming out of this thing whatsoever. So, yeah, I don't think this is working, unfortunately. And looking at all of our LEDs here, it's just going absolutely haywire. We've got all sorts of different errors flashing off and on here. Now I think this kind of thing possibly could work with perhaps a different type of tape, and it has actually already been pointed out to me that VHS doesn't actually have the necessary luminance bandwidth to record SIS, but that perhaps SVHS might. I had a look on eBay, and those machines are looking pretty expensive, so we're not going to be seeing one of them today, unfortunately. But anyway, this was a pretty interesting test, and as I said, perhaps it could be made to work if we throw a really expensive recording mechanism at it, but if we do that, in some senses we are kind of defeating the whole point of this. Well, I hope that you found this interesting. Originally I had a whole lot more planned for this video, including a full teardown of the equipment, but we have run on for far too long here, so I'm going to cut it at that, and me personally, I need a break from this. But we will be back here in maybe a few weeks or so with the rest of it. Anyway, that is all for now. Thank you for watching.